Hello there. Welcome to the milling tool creation walkthrough. This walkthrough is going to be broken up into 3 parts, with one part focusing on the creation of a rotary tool. The second part will be working on adding a user representation. And the third part will cover the creation of a holder and a complete tool assembly. Alright, let's get started on part 1. We're going to start simple, so creating a simple solid end mill will do. There are a wide variety of rotary tools from end mills to drills, and they all have the same general workflow. Under the Setup tab, you're going to find the Resource Creation button. Click on the type of component you want to create, and fill out the NC resource box by giving it an appropriate name. Remember, you will be working in a database that can reuse this component, so make sure you are naming and defining in a way that is sensible to you. Here you can define the tool's cutting motion type. Will this tool rotate to cut material? Remain stationary while the material moves? Or leave it default to the behavior of the operation? Sometimes machines are capable of cutting with both options, like this drill you see here. Of the 2 icons here, let's click on the Parameters one. It will open up parameters sections addressing different things. Geometry is prevalent in all tools we create, and these parameters should be filled out to complete the physical build of the tool. Usually, you can find the appropriate dimensions in the specifications of the tool from the OEM. Of course, every tool type will have additional parameters to accommodate their unique shape and application. Your tool should be spec'd out with the necessary information needed to complete the geometry. The Technology section is where you can set defining characteristics of the tool. That can be obvious things like the number of flutes or the rotating direction of the tool. It can also show some nuanced details to the tool that may or may not be important for you to set. If you do not know or care about the parameter, it's okay to skip over it. Just be aware that there can be options in your operations that may be dependent on the information you fill in here. As you can imagine, max plunge angle might play a critical role in determining if a toolpath strategy is viable, as opposed to, say, purchase cost. For those with post-processors that require it, syntax boxes like these will determine the kind of output seen in your program code. For example, this character string will output the through coolant code for your machine. The next section is feeds and speeds. This is where you can configure feeds and speeds for this tool. Specifically, if you want the tool to determine the feeds and speeds in your operation, they can be set here. You can add multiple configurations to the tool based on the material or machining scenario. The tooling intro video shows where in the preferences we can create these cutting conditions for feeds and speeds. Find the conditions you want to define them under, and then add them to the tool. If you have the necessary information, fill out the parameters to the best of your ability. I'll fill out a couple of these for our first example to give you an idea. I have speed mode here, and that lets me calculate the part of the feed and speed by either RPM, which is angular, or linear, which in our case is feet per minute. Next, for how we control the feed rate, are we calculating per tooth on this end mill? Or do we just move the tool globally and ignore the number of flutes we have? The actual feed rate here comes from you, the end user. Hopefully you are determining this by a proven feed rate or suggestion from the tool OEM. The next few fields here will auto-set the parameters in the operation if they are present. If you set these to 0, the parameter is considered null, and you will just have to fill it out manually in the operation later. Technology parameters are additional settings that can provide further refinement of the tool application. You can potentially set flood syntax for just this configuration. Here's a pro tip. You can export and import feed and speed configurations here, to and from a CSV file. If you want to try it out for yourself, export a configuration and observe the format of the parameters in the file. The compensation section allows you to pick default comp points on your tool, or add additional options that are then made available in the operation. If you click on Display All, you'll see the options that are current. As you can see here, P1 represents the tooltip, and P2 is offset from the corner radius value. The number of comp sites is always dependent on the tool type. For each comp site, you can assign a unique corrector ID, which is what becomes the output in your program code. For attachment types, The classes are created in the Preference section, similar to how you created feed and speed configurations. Take a moment and create additional classes if you would like to restrict the tools to a certain type of holder or attached resource. Part body color here should be self-explanatory. Choose the color you want to represent the regions of the tool. Alright, great. We've gone through the parameters of a typical Endmill. If all that you're doing is creating a tool, you can click on OK to create the NC resource. If you want to add a user representation to the tool, you click on this button to start that process. But we'll do that later. So, I'm just going to click on OK to complete our work here. And then close the resource creation box to take a look at what we built. Congrats! You created one tool. Obviously, you're going to make a lot more. But let's take a quick break from tool creation and move over to the Resource Config View tab. I'd like to show you how our new tool object exists in our manufacturing cell. I see it here under Tool Resources. I can right-click to delete, edit, or send the tool to a specific library. Before doing anything, now might be a good time to click on Save. The tool is not a part of your database yet, so any actions you'd like to take may or may not be available yet. If I go to the tree and click on Properties of the object, you'll see that it's an NCT object, thus searchable under that trigram. Alright, so this concludes our milling tool creation walkthrough. In our next video, we're going to add a user representation to this very tool. Thanks for watching, and I'll see you in the next one.